what is meant by drawing. Next one, what is meant by engineering drawing. What is the difference between drawing and engineering drawing? Okay, what is meant by drawing
Identify the outline.
and what is meant by engineering drawing? What is the difference between drawing and engineering drawing? Okay, again what is this? Again what is this? Now next, what is this? Okay, your point of view rectangle, again my point of view some other definition. Okay, some other definition. Again your point of view, what is this? Some other definition. Your point of view, again my point of view something. Okay, again how did you say this is a rectangle? How did you say this is a rectangle? How did you say this is a rectangle? Again my point of view, just I am going to assume square. Again your point of view rectangle. What happened here? Any graphical representation on a plane or a paper, any graphical representation on a plane or a paper, that is nothing but simple drawing. Again what happened here? Point to point, place to place, person to person, the definition of the object varies. The definition of the object varies. Just write on this. Drawing. Again the first day is completely theory class. Okay. Drawing. Any graphical representation, any graphical representation, any graphical representation on a plane or a paper, any graphical representation on a plane or a paper, on a plane or a paper, on a plane or a paper, known as a simple drawing. Any graphical representation on a plane or a paper known as a simple drawing. Known as simple drawing. Next, one more point. Again, what happened here? Point to point, place to place, person to person, the definition of the object varies. Okay, just start. Point to point, point to point, place to place, place to place, person to person, point to point, place to place, person to person. The definition of the object varies. The definition of the object varies. Next, coming to engineering drawing. Next, coming to engineering drawing. Engineering drawing. What is meant by engineering drawing? First of all, a drawing prepared by engineer for engineering purpose. For engineering purpose. Again, it shows the physical object. It shows the physical object and some standard representations and relationship between other designs. Okay. A drawing prepared by engineer for engineering purpose. It shows the physical object. It shows the physical object and relationships and some standard relationship, and it shows the some standard relationship. Okay. Now see here, a drawing prepared by engineer. Okay. Again, it means drawing. Just I am going to design one thing. A drawing prepared by engineer for engineering purpose. What is the purpose? Engineering purpose. A drawing prepared for engineering purpose. Just I am going to design one drawing. Again, what is the purpose of this one? Engineering purpose. Again, mechanical point of view, what is the engineering purpose? Manufacturing. Again, civil point of view, construction. Okay. Again, by using this design, by using this drawing, I am going to prepare the product. Again, same thing, construct the different types of structures. Okay. That is the purpose. Again, it means engineering drawing. Drawing shows the physical object. Physical object means real-time object. The drawing shows real-time object and some standard relationships. Nothing but standard relationships. Nothing but dimensional standards. Next one, constraint standards. Next, some symbolic standards. Okay, just write up to this. A drawing prepared by engineer. A drawing prepared by engineer. A drawing prepared by engineer. A drawing prepared by engineer for engineering purpose. A drawing prepared by engineer for engineering purpose. It shows the physical object. It shows the physical object. It shows the physical object. It shows the physical object and some standard relationships. And some standard relationship. Again, what are the different types of standards? Dimensional standards, constraint standards, and symbolic standards. Okay. Now you can see, for example, these two. Okay. Again, what is this? Again, this is one circle. Nothing but one simple. First of all, some graphical representation on a plane or a paper. Okay. Simple known as a drawing. Again, my drawing contains some standards. My drawing contains some standards. What are the different types of standards? Currently, for this example, dimensional and symbolic standards. Okay. Now see here. Dimension means radius. Okay. Then again, this is the point representation. Nothing but center mark. Symbolic representation. Again, what happened? Your point of view, circle. Again, my point of also circle. Your point of also circle. Again, my point of view also circle. Again, what happened here? Point to point, place to place, person to person. Definition is same. Definition is same. Again, coming to this one. Again, these are the equal dimensional standards. Again, these are the constraint standards. Constraint standards. Nothing but this line and this line parallel to each other. This one and this one parallel to each other. Again, this one and this one perpendicular to each other. That is nothing but symbolic standards. Sorry, constraint standards. Okay, just write. Again, what happened here? Point to point, place to place, person to person. The definition of the object remain same. Just write. Point to point, place to place, person to person. The definition of the object remains same. The definition of the object remains same. Okay. Next one. That is about the drawing and engineering. Next one. What are the basic geometrical shapes? What are the basic geometrical shapes? Basic geometrical shapes. What are the basic geometrical shapes? Points. Next, joining of points gives lines. Joining of lines gives polygons. Polygons. Nothing but triangle. 4 means square or rectangle. 5 means pentagon. 6 means hexagon. 7 means heptagon. 8 means 9 means anagon. 10 means decagon. Okay. Now next one. Now these are some linear profiles. Then coming to angular profiles, arc. Again you can rotate arc completely 360 circles. Again radius of curvature. Then again next parabola, ellipse, hyperbola. Again one more one, spline. Okay. These are the basic geometrical shapes. Again you can design any type of design. You can design any type of design by using these simple basic geometries. By using these simple basic geometries. Okay, but we can apply some modified tools. Okay, keep in mind we can apply some modified tools by using simple geometries and some modified tools. We can design any type of shape. Okay. Then next one, what is meant by projection? Just write down projection. Before going to that one, first see here 1D, 2D, 3D. 1D means one dimension. Now see, in the universe, just I am going to design one line. Okay, just I am going to design one line. Now this line horizontal to, this line is horizontal to earth surface. Nothing but this is the, now this line parallel to ground. Again this is nothing but horizontal line. Okay, and also you can treat as a x-axis. Okay, then I am going to design one more line. Okay, this one perpendicular to ground. This is nothing but vertical line, and we can also known as y-axis. Okay, then again one more one. Okay, one more one. This is the z-axis. Okay, perpendicular to x and y. Just simple representation, this format, x, y, z. Now you can see in the universe anything in three-dimensional format. In the entire universe, anything in the format of three-dimensional. Every component having x dimension, y dimension, and also z dimension. X, y, and z dimension. Okay. Now anything in the universe in the format of 3D. Anything in the format of 3D. But our assumption purpose, for our analysis purpose, just you can set some assumptions. For that purpose, you can treat 1D, 2D, 3D. 1D, 2D, 3D. Now three-dimensional region means 3D space. Now this is the 3D space. Okay. Again this room having length, width, and height. This room. This is nothing but three-dimensional space. Again 2D means two-dimensional region. Okay. Just see here. Again this room having how many planes? How many 2D regions? This room having how many two-dimensional regions? 6. Now this one, first one, second, third, fourth, total 4, 5, 6. Total how many regions? 6 regions. Any 3D component having total 6 2D regions. Okay. Now see here, you can write anything, we can design anything on plane. Plane is nothing but a simple 2D region. Plane is nothing but a simple 2D region. Now see here, board also one 2D region. Now see here, board, again this is the length, again this is the height. Simple x and y. How many dimensions? Only 2 dimensions. Now I am going to design anything on, now this is the 3-dimensional place. Now you can write anything in 3-dimensional? Not possible. That means you can design or write anything on plane. Just I am going to design writing something in this plane or in this plane, or your paper also one simple plane, simple 2D region. Okay. Now see here, you can define anything by using single dimension. Okay. Now see here, now I am going to design on a small thread, very small thickness. Okay, small diameter circular thread. Again length equal to 1000. Okay, length equal to 1000. For analysis purpose, we can assume, we can neglect the diameter. That means the diameter is some 0.05. Again compared to this one with respect to this one, for analysis purpose, we can neglect the diameter. Now we can treat this element is a 1D element. Again you can see different analysis softwares for ANSYS and StatPro softwares. Again the analysis is in this pattern: 1-dimensional objects, 2-dimensional, 3-dimensional objects. 1-dimensional means just you can treat as a, now you can see beams. Okay, for beams analysis we can treat as a 1 dimension. Y means beam having length. Just we can design two nodes. Just I am going to join these two nodes. Now how many dimensions are helpful here? What are the input? Just you can specify the length of the line. Nothing but beam length. That is nothing but beam length. How many parameters you can use here? Only one parameter. That means you can define this one by using one dimension. Background you can mention. Background of this one you can mention remaining values. What is the cross section? What is the cross sectional width value? Everything. Now this is nothing but one dimensional analysis. Then again I am going to analyze some plate in this format. Some thin plate. Now this is nothing but thickness. Okay. Again compared to length and width, the thickness is very small. Thickness is very small. Again you can neglect this one. Again you can done the analysis on this component. Again this component having how many dimensions? Again length and width. Again this is the 2D analysis. Directly you can done analysis on 3-dimensional object. Okay. 1D, 2D and 3D. Okay. In the same pattern, 1-dimensional, 2-dimensional, 3-dimensional. Now you have only one dimension. You can find out which one. Now see here. We have only this dimension. Just you can assume. Okay. Now this is some rectangle. Now I am going to mention only this value. Now this component having how many values? Only one value. By using one value you can find out only length. You can find out only length. Length is nothing but distance between two endpoints. You can find out only length. Now again I am going to assign two dimensions. Okay. You can find out length and also this one. Horizontal one known as a length. Again this one as a width. You can find out distance between these two endpoints. Again these two endpoints. Again you can combine these two values. Just now single. Now only one dimension. That means you can find out distance between endpoints. Now I am going to use only this dimension. You can find out length. Again I am going to use only width. You can find out the width value. Okay. Now I am going to combine these two dimensions. Just I am going to combine these two dimensions. Length into width gives area. Length into width gives length related to 1D, area related to 2D. Okay. Again you can, for area purpose, for find outing area you need two dimensions. Again same thing, circle also, pi by 4 d square. D square means d into d, 2 dimensions. Then next one, 3-dimensional object. Okay. Now same length, width and height. Now I am going to use only this one. You can find out only length. I am going to use only this one. Width. Again I am going to use only this one. Height. Now I am going to combine these two. Again this one and this one. You can find out area of this face. Again the same pattern. I am going to use height and this length. You can find out area of this plane. Again the same pattern. Again I am going to use all the 3 dimensions. You can find out volume. For volume purpose you need 3 dimensions. That is 1D, 2D, 3D. Okay. Again just see here. Same thing, I am going to represent x, y, z. Again you can see the planes x, y, z. Total coordinate section axis, x coordinate, y coordinate and z coordinate. Now this is nothing but 3D space representation. X, y and z. Okay, anything. Now see here. Now this is the z. Okay. Again you can see in this direction this plane is what plane? This plane is what plane? YZ plane. Okay. Again this plane is what plane? XZ plane. Again this one is the which one? XY plane. Same this pattern. Again this is the what plane? That's depend upon your axis. Depend upon axis. Again I am going to assign this is the x. Again height is the y. Again this one is the z. That means this is the x. This is the y. Again this is the z. Again this one is the xz plane. Again this one is the x. Okay. That is the planes. Okay. Any 3D space.
So నార్మల్ మనం z జెడ్ని వ్యూ చేస్తే నార్మల్ వ్యూలో 2Dలో
చేంజ్ చేసుకోవచ్చు మనం. ఆ XYZ మనం ఎలా అయినా రిప్రజెంట్ చేసుకోవచ్చు.
నార్మల్ విజిబిలిటీలో జెడ్ అనేది మనకి ఐకి విజిబిలిటీ ఉంది
2Dలోనా చేసుకోవచ్చు సాఫ్ట్వేర్లో.
ఇప్పుడు మామూలుగా ఇప్పుడు ఈ రూమ్ ఎగ్జాంపుల్ తీసుకున్నాను. ఈ 2Dయా 3Dయా?
రూమ్ అయితే 3D స్పేస్.
3D స్పేస్.
ఇది 3D రూమ్, 3D వాల్యూమ్. ఇదంతా వాల్యూమ్ కదా. వాల్యూమ్ అంటే లెంత్, విడ్త్, హైట్ ఆర్ థిక్నెస్. ఓకే, అగైన్ జస్ట్ యూ కెన్ ట్రీట్ యాజ్ ఏ 2D. 2D అంటే ఏమొచ్చింది, ఈ వాల్ వచ్చింది. ఇక్కడ 2D రీజన్స్ ఏమేమి ఉన్నాయి, జస్ట్ ఓన్లీ 2D రీజన్స్. ఇది ఉంది, అది ఉంది, అది ఉంది, మొత్తం టోటల్ 6 ఉంటాయి. ఇండివిజువల్గా తీసుకోవాలి 2D రీజన్ అంటే. ఓకే, జస్ట్ యూ కెన్ సీ ఎనీ ఆబ్జెక్ట్. జస్ట్ ఫర్ ఎగ్జాంపుల్ క్యూబ్, హౌ మెనీ total? This is the one plane, one face. Total how many faces? Second, third, fourth, fifth, sixth. Same thing this one also. Okay, any 3D object. Okay, then next projection. Write down the projection. Again see here, now I am going to design something. Now I am going to design one cube. See here, now I am going to design cube, one cube. Now I am going to design one cube. How to design the cube? Now this is the 3D space. Just I am going to design in this area. What happened? Not possible. You can design anything. You can write anything on plane or paper. Why means this is a one 2D region. Paper also one 2D region. Now this is the 3D space. In this 3D space not possible. 3D space is not possible. For visibility purpose not possible. Imaginary purpose okay. Imaginary purpose okay. Just I am going to represent in this format. Imaginary purpose okay. For reality purpose, for representation purpose,
2D.
you must and should take 2D. We can represent anything on 2D region. Now this is on 2D region. 2D region is nothing but plane. 2D region is nothing but plane. Again just I am going to represent in this format. Okay. Again plane or paper. Both are 2D regions. Okay. Now next one. Projection. Representation of just any graphical representation. Any graphical representation. Any graphical representation. Any graphical representation. Just wait. Just add just representation of any. Just wait. Just wait. You can represent any graphical representation. You can represent any graphical representation. You can represent any graphical representation on a plane or a paper. On a plane or a paper by using projecting principles. By using projecting principles. By using projecting principles. By using projecting principles. Okay. By using projecting principles. Next point. Projections are classified into. Projections are classified into two types. Projections are classified into. Projections are classified into. Projections are classified into two types. First one is the orthographic projection. Orthographic projection. Next one is the pictorial views. First one is the orthographic projection. Second one is the pictorial views. Pictorial views. Okay. Let's take a main heading orthographic projection. Main heading orthographic projection. Orthographic projection. Orthographic projection. In bracket, nothing but 2D views. Orthographic projection is also known as a 2D views. In bracket. Also known as a 2D views. Okay. Just add. Definition: any graphical representation. Any graphical representation plane or a paper in the format of 2D. In the format of 2D. In the format of 2D. Okay. That is nothing but ఓకే నేను స్టార్టింగ్లో ఏం చేస్తానంటే ఎనీ తీసేసి రిప్రజెంట్ 3D గ్రాఫికల్ రిప్రజెంటేషన్ ఎనీ తీసేసి రిప్రజెంట్ 3D గ్రాఫికల్ రిప్రజెంటేషన్ represent 3D object represent 3D object graphical representation of a 3D object on a plane or a paper in the format of 2D. Representation of a 3D object on a plane or a paper in the format of 2D, known as a orthographic projection. Now see here. Again, this is one object. Now, with respect to me, each one with respect to yours. Again, this object. First of all, this object having how many faces? Total. This object having how many faces? Total 6 faces. First, second, third, fourth, fifth, 6. Total 6 faces. Again, with respect to yours. Which one is the front face? With respect to yours, this is the front face. Again, front opposite, back face or rear face. Front face. With respect to yours, this is the front face. Again, this is the back face. Again, this is the top face. Okay. Again, this is the bottom. Again, this is the okay. This one and this one is the side view. Again, with respect to yours, this is the what side view? Which type of side view? With respect to yours, left side view. This is the right side view. Okay. Any 3D object having total 6 faces. With respect to observation, we have total how many views? 6 views. Total 6 views. Now this is one 3D object. Now I am going to represent this 3D object on a plane or a paper in the format of 2D. Now this is 3D object. We can represent this 3D object on a plane or a paper in the format of 2D. Now how to represent the 3D object on plane or a paper? By using views. Any component having total 6 views. By using these 6 views, you can represent 3D object in the format of 2D on a plane or paper. Okay. Now with respect to your, which one is the front face? Now see here. Just I am going to send the light ray. What happened? Just I am going to send the light ray. What happened? The light ray touches to the light ray falls on with respect to yours. This is the light ray direction. This is the with respect to light ray. This is the front view. Okay. Now front. Just the light ray. All light rays falls on front view. The front view shadow falls on plane. Same thing here. Light, shadow. Okay. Same thing. Your eye also one light ray. Again, you can think imagination. Okay. By using that imagination, nothing but projection principle. Okay. Just you can design the front view. Okay. Okay. Again, this one with respect to yours in this format. Okay, this is the front view. Again, next one. Again, you can see top. What is the top view? Just you can represent only simple square or rectangle, depend upon the dimensions with respect to these edges. Again, you can represent side view. Side is only okay. This is the side view. Okay, 3 views are enough for representation one 3D object. 3 views are enough for representing one 3D object. Okay. Again, the same format. This is the front view, top view. This is the left hand side. Just write down this. Again, next write down. Orthographic projections classified into 6 types.
So projection is nothing but representation on a plane or surface.
Same thing. Same drawing and orthographic projections classified into 6 types. Orthographic project is classified into six types. First one is the front view. Front view. By projecting means just you can project the rays. Just you can project the rays. The shadow falls on the same thing. The light rays are known as a projectors. Same thing. The light rays are known as a, for drawing language, for physical object, for physics purpose, light rays. Again same thing with respect to light. Just imaginary purpose, projectors known as a projectors. Same. All projectors are parallel to each other. Now see here. All projectors are parallel to each other, and just the shadow falls on in this location by using projectors. Again what happened? What is the angle here with respect to plane and projector? What is the angle? 90 degrees. 90 means perpendicular. Perpendicular means ortho. Now what type of projection? Projection is nothing but representation of any graphical representation on a plane or paper. What type of projection? So see here. Object, all light rays, one by all light rays. Okay. All light rays are known as a projectors. All projectors are parallel to each other. Now see here, all projectors. Now this is the first again projector, all projectors parallel to each other and perpendicular to the plane. Perpendicular to the just see here, all projectors. Just assume all the projectors. Just I am going to join all the projectors. Okay. Now I am going to create one graphical representation. Just I am going to create one graphical representation. How to create this graphical representation? By using projection. By using projection. By using projection, just I am going to create one. Just I am going to create the simple geometry. Some simple geometry. What is the principle here? How to create these projector points? Nothing but just touching point of the plane. Now in this location, what happened? With respect to plane and projector, what is the angle between these two? 90 degrees. 90 degrees means perpendicular. Perpendicular means ortho. Simple thing. So this is one type of projection. So orthographic projection. Again, this projection is nothing but front face. This projection is nothing but front face. So this is known as a front view of the object. Okay. Next one is the front view. Opposite, back view. Second one, back view or rear view. Orthographic projection is classified into 6 types. Front view. Next one is the back view or rear view. Next one is the top view. Top opposite. Top view. Next one is the top opposite. Bottom view. Bottom view. Next one is the left hand side view. Next one is the right hand side. Okay. Right hand side. That is about the orthographic. Again next.
6 ఉంటే అప్పుడు 3D అయింది కదా సార్
6 ఉంటే 3D ఎందుకు అయింది?
3
చెప్పు
మామూలుగా ఫ్రంట్ టు బ్యాక్ టాప్ మీన్ వచ్చాయంటే 3D లో ఇస్తుంది.
అదే 3D ఆబ్జెక్ట్ ని 2D లో రిప్రజెంట్ చేస్తున్నాను నేను. యాక్చువల్గా ఇది నా 3D ఆబ్జెక్ట్. దిస్ వన్ ఇస్ మై 3D ఆబ్జెక్ట్. నేను ఎలా రిప్రజెంట్ చేస్తున్నాను ప్లేన్ లో? నా డ్రాయింగ్ ఎలా చేస్తున్నాను? 2 డైమెన్షన్ ఫామ్ లో రిప్రజెంట్ చేస్తున్నాను. ఒక క్యూబ్ చూడు, ఇదే ఫార్మాట్ లో ఉంది. టోటల్ డ్రాయింగ్ 3 డైమెన్షన్ ఫార్మాట్ లో ఉంది. ఈ 3 డైమెన్షన్ లో ఉన్న again we can represent this drawing in the format of 2D. This is the front view, top view, side view. Okay now this is the 3D representation. Again this is the 3D representation, 3D object representation in the format of 2D. Okay, again same thing, front view and back view both similar to each other, parallel to each other. Again left hand side view, right hand side view similar to each other. Again top view and bottom view similar to each other. For that purpose you can represent any 3D object by using 3 views enough. Okay, For clarity purpose, you can design many views. The next one, methods to generate orthographic projections. 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 We have two methods. First angle projection. Second one is the third angle projection. First angle projection and second one is the third angle. Okay, again when adding first angle projection. Just write down. In first angle projection, the object present in the first quadrant, object present in the first quadrant, object present in the first quadrant. Next, second point. The object lies between observer and plane of projection. Next point, first angle is a Indian standard. First angle is a Indian standard. Just took a 4 lines gap will be a page will be.
The views and ఎవరు రిప్రజెంట్ చేస్తుంది ఇంట్రడ్యూస్ చేసినట్టు.
Okay, next one. Third angle projection. In third angle projection, the object present in the third quadrant. In third angle projection, the object present in the third quadrant. Next, plane of projection lies between observer and object. Third point, it is a USA standard. Now see here, just I am going to design one line. Now this is nothing but horizontal line, x-axis. Again one more one, vertical line, y-axis. Again the intersection point known as a origin point. Okay. Now this is nothing but simple x-axis and y-axis. Now again I am going to create planes. Just I am going to design one plane. That means horizontal region. Again next same thing. One more plane. Same in this format. This is the horizontal plane. This is the vertical plane. Same in this format. Vertical plane and horizontal plane. Horizontal plane, vertical plane. Again this is the first quadrant, second quadrant, third, and this one is the fourth quadrant. Okay, first, second, third, and fourth quadrant. Again, first one is first angle projection. First angle projection. In first angle projection, the object present in the just wait. The object present in the which quadrant? The object present in the first quadrant. Again, object present in the first quadrant. Second point is the object lies between observer and plane of projection. Plane of projection. Now this is one plane. Okay. Now this is the with respect to observer. Again same thing here. Vertical plane, horizontal plane, observer. Again that is the vertical plane, horizontal plane, observer. Which one is the front face? Again this is the front face. Again this is the with respect to me. Again this is the front. Again this is the top, bottom, left side. Again this is the right hand side. Just I am going to send the light ray. What happened? Just I am going to send the light ray. The shadow taking on which plane? Vertical plane. That is nothing but plane of projection. Plane of projection. So front view taking on which plane? Vertical plane. Front view taking on front view falls on vertical plane. Same thing here. Now with respect to observer, this is the front. Now these are nothing but dotted lines, projectors. Just I am going to join this correct man. Okay. Then again same thing. This is the front view. Again this is the top view. Just I am going to send the light ray in this direction. What happened? The shadow falls on nothing but projection falls on horizontal plane. Same thing in this direction. Now this is the front view. This is the top view. Now what happened? This is the 3D representation. Now see here. Again I am going to represent in this format, Again what type of representation? This one is 3D representation. Again we can represent entire thing on single plane. You can represent, now this is the horizontal plane, this is the vertical plane. Again you can represent entire thing in single plane. Okay? Single plane. Single plane means for that purpose, for visibility purpose, we can rotate 90 degrees clockwise. 90 degrees clockwise. Just what happened? I am going to turn the horizontal plane 90 degrees clockwise. What happened? Now with respect to origin, just I am going to design one reference line. Now above the reference is the front view. Now same thing, front view taking above the reference. Just I am going to turn this one. What happened? Top view coming to bottom side. Okay. Why clockwise direction? Why not anti-clockwise? Why clockwise?
Clockwise first angle.
No. Why? Just no. Just I am going to turn in this direction. What happened?
Front and top view.
Both are merging, overlapping. That is not a correct view representation. Just I am going to turn in this direction. What happened? Again you can represent same in this form. Okay. For single plane representation, you can turn horizontal plane clockwise direction. Okay. Again same thing here. Now this is the left side. This is the right side. Again I am going to send light in this direction. The shadow taking at which plane? The left side. The left side taking right side. Again right side shadow taking left side. Same thing here. Again this is the right hand side view. This is the left hand side view. Top view opposite bottom view. Again front view same thing. Back view. Both you can represent in this format. How to represent background views? By using dotted lines. Okay. By using dotted lines. That is about the representation. Again you can see the symbolic representation. What is the symbolic representation of first angle? Again you can see different types of drawing sheets. Again in this title block we can represent type of projection. Okay. Now this is the symbolic representation of the first angle projection. Just like that. మొత్తం ఇందాక గ్యాప్ స్పేస్ ఉంది కదా గ్యాప్లో. Now this is the symbolic representation. symbolic representation of first angle projection. Next, view representation. Example. Okay. Now see, for this example, object present in the third quadrant, same thing, observer, plane of projection. Again, we can apply the extracting principle. Just I am going to extract this one. Now this is nothing but, now this is the direction here, direction of viewing. Again this is the projecting. Again same thing, this one. Again same in this direction. Now in this location, this is the direction. Again this is the top view. Again in the same format, again front extracting. Just we can extract this view with respect to this plane. Again extract this one with respect to horizontal plane. Again same thing, extract left to left side. Again extract right to right side. Simple. Again you can turn clockwise 90 degrees. Again clockwise. just wait. Clockwise 90 degrees. Again above the reference is this time. Top view is the above the reference, same thing. Just I am going to turn this one. Above the reference is the top view. Again below the reference is the front view. Again next one, left hand side view. Left side taking left side. Again right side taking right hand side view. Again top view opposite bottom view. Okay. Again the symbolic representation is, this is the symbolic representation of the third angle projection. Okay. Just try. Third angle. Again in third angle projection, what happened? Plane of projection lies between object and observer. Now in this object lies between plane of projection and, again you can design or write anything on plane. Now for that purpose I am going to project. Just I am going to send the light ray, the shadow taking on this plane. Again you can send this one, shadow taking on this plane. Okay. Next same thing, left side, right side, left side. Again same thing here. Now just I am going to send the light ray. What happened? The light ray cannot fall on the object. Why means? Plane. Some central plane location. Central lo emundi? Plane. Just in object next room lo undi. Now this is the plane of projection. So light rays object may follow here. Again you can apply the extracting principle. Extracting. Just I am going to extract. This is the, with respect to observer, this is the front view. Just extract this one, which plane? Vertical plane.
Yeah, plane means ki project chestam sir.
Same thing.
Third quadrant loki
third quadrant nunchi
fourth quadrant loki project
plane మీద project చేస్తాం.
plane మీద project చేస్తాం.
Okay na? Next this one also, this one. Again this is the 3D representation. Again same principle, clockwise 90 degrees. Same thing, clockwise 90 degrees. Again what happened this time? Above the reference is the top view. Again below the reference is the front view. Same thing, remaining things also. Left side left extract, right side right extract. Again this is the symbolic representation. Okay na?
Yes.
Okay. That is about the